We are back again with OUDP Leakage Detection Explained. I'm Brady Volpe, founder of Nimble This and the Volpe Firm. We're back with another episode of all things DOCSIS. With us today is Flavio Marcon, product support specialist at Effigis Geo Solutions. Flavio, welcome to the show. Your first time on. Tell us a little bit about yourself and where you're broadcasting from.
Well, thank you, Brady. Yes, so my name is Flavio Marcon. I am with Effigis Geo Solutions from Montreal, Quebec, Canada. All right. I'm a product support specialist for the CPAT line of leakage, monitoring and location, and as well as the ingress detection system. I've been in the industry for probably around 35 years now. So time flies and it's still fun. So
outstanding.
That's it.
Thank you, Flavio. Also with us is Jason Miller, technical marketing engineer at Cisco Systems. Jason, you've also been on a show with us. Glad to have you back.
Yeah, thanks for having me back. Yep, I'm still transmitting from the sticks, kind of north of New Orleans in Louisiana. And I've been at Cisco for 23 years now, and a good chunk of those working with cable industry.
Outstanding, Jason. And John Downey, a long-time supporter of the show and always with us, senior CMTS technical leader at Cisco Systems. John, good to have you back once again. How you doing, John?
It's always great to add color commentary. I'm just here for humor.
You're the anchor of the show, John. Good to have you with us. So today we're going to be talking about OUDP leakage detection, why you should be concerned about it, why you should understand it. We're going to talk a little bit through it. But before we start on that, we think you should understand, what is leakage, why we test it, and how you test it. To start off with that, I'm going to ask Flavio to start us off in that conversation. So Flavio at Effigis, I think you know a little bit about leakage testing. Flavio, what is leakage testing? Why should we be concerned about it? Can you just give us a quick intro?
Okay, sure. Well, absolutely. So leakage testing is a mandatory, maintenance operation that needs to be done with the cable operators. It's twofold. Okay, one, of course, it's maintenance of the coaxial plant. Okay, to ensure the integrity, if you want, or the good quality of the coaxial plant in order to provide good services to the customers and subscribers. But the other portion as well that we've been doing for many, many years, of course, is in order to ensure that the frequencies that we're using, as well as the aeronautical band, are not being interfered. Okay, so there is a requirement, okay, that the aeronautical band, okay, be monitored, okay, and be reported, being done every quarter, to ensure that a certain limit, okay, is not surpassed as far as energy that's being irradiated from the coaxial plant.
Right. So we're always transmitting signals from the head end or hub sites down to our customers. And what you're saying is we don't want those signals to leak out of our coax plant and impact other services, whether that could be airplanes flying overhead or LTE or your cell phone signals and things like that. Our signals in a coax plant can impact those. So this leakage testing that you're talking about is we're trying to actually measure if our cable plant is allowing these signals to leak out.
That's correct.
So what, are there government bodies that are concerned about these signals?
Yes, there are government bodies. The FCC, of course, requires that all cable operators submit quarterly reports. Okay, up here in Industry Canada, we have essentially the same type, okay, of reporting requirements that need to be done, although not as frequently. Okay, but essentially the basics of it, okay, remain the same. We have to respect a certain cumulative leakage index, okay, for the licensed operator, okay, does not surpass the number of the figure of 64. Okay, so that's is a sort of a measuring stick, okay, telling the government bodies, okay, that we're within the limits, okay, of the RF energy that's being emitted from the cable plant in the aeronautical band. Of course, we're also doing leakage now in the LT band, the higher frequencies, okay, because we are there too, sharing spectrum, okay, with the cellular operators, okay, and therefore we could, in fact, be interfering with the cellular operators, okay, but as well, okay, wherever there is a leak at a certain frequency or an egress from the plant, okay, you would always also have ingress into the plant. So it's a twofold, if you want to say twofold maintenance operation.
So I would say that, we have a requirement and it's mediocre stringent, but as cable operators, we are more stringent trying to give good quality to our customer. So we have a certain number to reach for FAA, FCC, no interference to aero navigation. But we definitely don't want that stuff interfering with our signal. And but with that in mind, we also know a leak at, say, 138 megahertz doesn't mean that a smaller hole doesn't let in 27 megahertz. Or
correct.
Frequencies can be very finicky. You don't know where they're coming from, and you could look for leakage at 138 and say, hey, everything's fine. But as cable operators, we're usually looking for even tighter numbers than what the FCC wants, because we don't want any leakage, right? We don't want it, because any leakage probably means ingress as well. That's sort of the way I look at it. And we talked about there could be a flyover, but not many people have puddle jumpers or crop dusters that they can have access to do a flyover to actually measure the RF energy at certain levels. So we do cumulative leakage index, CLI, and that's a ride around, right? And detecting leakage through your plant and then using formulas to figure out what that cumulative leakage index is.
So you talk about flyovers and stuff, but how generally do we measure leakage today in a cable plant? Because, I mean, we have miles and miles of cable plant going everywhere. It could be through cities, could be through rural areas. How traditionally are we measuring this leakage? Flavio, could you help us out?
Well, yep, absolutely. So, typically what John just mentioned as far as the ride outs, okay, these ride outs are done on a quarterly basis, okay. And what we're doing is we're measuring and recording, okay, all the leaks, okay, that are 50 microvolts per meter or higher. Okay, and it's these leakage, we call them events. These leakage events are plugged into a formula, okay, that is used to calculate the CLI based on the total plant mileage, okay, that's in the footprint or the PSID, okay, and compared to the patrolled plant that was done during the ride out. And with that formula, then you get your CLI figure as a pass or fail.
You might outfit all your RF text bands with the gear to detect, but your test equipment inserts a signal at the head end, right?
Right.
And then it broadcasts out from the head end out everywhere. But that signal also has a signature to it, correct?
Correct.
Like a tag. They might call it a tag or a frequency shift key or something of that nature.
Correct. So that kind of an approach is used in order to. It initially was used to with overbuilders, okay, not to confuse when all analog signals were available, not to confuse the two plants, okay, which one was leaking. But in today, yes, with the technologies we have today, as far as the tagging, if you want, of the injected signals, okay, we are eliminating any, or as much as possible, any possibilities of recording any false leaks that are actually coming from the plant. Since the leakage detectors, essentially what they are, they're receiving an off-air spectrum. So anything that's off-air is being received by the leakage detector. So we want to identify it, okay, to make sure it is a signal that we are injecting in the plant, and strictly use those, for as far as the calculations.
So, Jason, before we get into OUDP, which we're going to get into that in just a moment, if we look at DOCSIS, 1X, 2.0, 3.0 modems, is there anything in CMTSs or cable modems prior to DOCSIS 3.1 that would give us the ability to do any type of leakage measurement or have any visibility into leakage in, pre-DOCSIS 3.1 CMTSs and cable modems?
Yeah, I mean, I think, and the stuff that Flavio talked about, we were just doing it more in the downstream direction today. And that's just because in prior DOCSIS versions, 85 megahertz was the biggest split that we had. So the aeronautical has always been something that we've been a lot more focused on because of the FAA regulations. So it really wasn't until we moved to DOCSIS 3.1 that we were concerned about how to do that on the upstream, which is, I think, we're probably going to talk about here later on.
Right. Awesome.
Let me add, Brady. The question was, I don't know, a little gray. You said, was there anything in older modems to detect egress or leakage? But I would counter that with saying you had full bandwidth capture that could detect ingress.
Right.
Right.
And that's one of the things that we had a benefit of with full band capture. We could see if maybe there was a large FM signal leaking in, or maybe if there was unused spectrum, we could see LTE. And that's kind of what you're getting with full band capture, John, where we could see something if it was large and leaking in.
Leaking. Ingress in.
Ingress in, yes.
When I say leaking, I think
ingressing.
I'm thinking out.
Ingressing.
Let's say ingress.
That makes sense. Okay, so we kind of covered what leakage is, how we test it a little bit, but things are changing in our network. We're moving to what's called a high split plant, where you may have a 42 megahertz return today. That's going to grow to an 85 megahertz, eventually a 204 megahertz return, and there's a lot of talk that this is going to change the way we're doing ingress or leakage testing today. And so why is that? Why will that impact the way going to a high split plant? Why is that going to change the way that we test leakage today? Flavio, I'll let you take that first.
Yeah, so the what we have to do now with the 204 high split thing is we have to determine a way how to do leakage detection in that sacred aeronautical band. As far as the FCC is concerned, they don't care if it's upstream, downstream, no stream. You have to respect their specifications for in the aeronautical band. Okay, so that being said, okay, since now the 204 is all up in the upstream, okay, obviously we cannot use our traditional legacy injection or detection, okay, of specific frequencies or carriers, okay, that are inserted in the downstream. Okay, so we have to find a solution, okay, to be able to do leakage detection with signals that are coming from the actual subscribers, or other upstream from the subscribers back to the RPD or the head end, and that's where the OUDP concept was brought about. There are other solutions that have been put on the table, okay, but after several work on it, okay, it was deemed that the OUDP method was actually going to be something that be a lot simpler to do and possible to do with the technology we have today.
As a devil's advocate, let me throw a few things, and Jason can answer this too, I think. What if someone said, let's just avoid the frequencies altogether? How much would we lose if we really tried to just avoid the FAA frequencies? Like, don't even use them for our upstream. Could we do that? I've heard people say that, but I think we lose a lot more than you would think.
You could, yeah. That's valuable bandwidth that you're losing.
Exactly.
Yeah, about 30 megahertz.
Mm-hmm.
Yeah, that's a good chunk.
I mean,
it's a good chunk,
right? And it's good spectrum too. I mean, it's one thing if you lost 30 megahertz at 5 to some stuff like that, but we're talking like 108, 137, somewhere in there. This is good spectrum. Probably stuff that you're going to run higher order modulations. To answer your question, yes, you can. We certainly always have supported exclusion bands. You could put exclusion bands. I think some of the early people to deploy did that just to be very conservative until they had a time where they could do out of band testing on the upstream side. I mean, testing on the upstream for leakage detection.
But it is prime real estate. It's going to be like very, very clean spectrum that we can
Yeah.
use. So so yeah, I mean, going to 204 megahertz, as Flavio indicated, what used to be downstream is now becoming upstream. So we can no longer put our leakage head end leakage detection injection system in our head end and broadcast our leakage detection signals. Now they have to come from our subscribers' home. So this takes us into the concept of using ODP burst signals. But before we can even talk about OUDP burst signals, we have to talk about what is OUDP. And Jason, I'll let you explain what does OUDP mean?
Yeah, I mean, what it really means, it's an OFDM Upstream Data Profile, and it's always been around. We've just shortened it because now it's kind of been used a lot more in the context of leakage detection that we just say OUDP. But it was just like on the downstream for DOCSIS 3.1, we could have multiple modulation orders supported in one channel. We have that on the upstream, and these OUDPs get assigned to modems, and they actually use the interval usage code, and that's how we can have different modulation orders being used on the same upstream channel. So that was what OUDP is. The OUDP test burst then has always also been a function of DOCSIS 3.1, and what that allows you to do is you could go in if you want to test to see if a modem could support a higher order modulation. You could use this test burst to tell the modem to use this particular interval usage code that might correspond to 2048 QAM. And then you could see if the modem transmits clean in there. Cisco didn't use that. We use something called probing, where we measure receive MER for all the subcarriers and then assign the OUDP to the modem based on that.
Okay, so OUDP is part of the standard DOCSIS protocol, and it's really just the way the modems are assigned their modulation profiles based on the amount of noise. Less noise means they can transmit at higher modulation profiles. More noise, they're going to transmit at lower modulation profiles. Is that basically sum it up, Jason?
Exactly, right. Yeah.
And now to take it further, you're saying this OUDP test burst that the modems has, that's part of the communication between the modem and the CMTS, where the modem's sort of testing the waters to see if it can run at a higher order modulation when it sends out this OUDP test burst. Is that kind of how that's working?
That's how it would work. That's right. And again, Cisco didn't necessarily deploy it for that functionality, but right, that's how it would work. If we wanted to see, let's say today you're running 512 QAM, we want to see if you could do a higher order modulation. We would tell you to do a test burst on that particular IUC, and we would measure what the kind of performance was, code word errors, that kind of thing.
Yes, and I don't think Cisco's the only one who didn't take advantage of the OUDP test burst. There a lot of people, a lot of different vendors have gone like to an RxMER sounding, where they use the RxMER data in order to see what is the more available profile. So it's like we come out with good ideas in DOCSIS, and then vendors choose different implementations. So it's all good. We're all friends here.
One of the things there too that was also, there's a limit that the modems only need to support, or they can only support up to 2 OFDM or OUDPs at a time. So they only assign 2 at a time, even though you could have 7 defined on a channel. So that kind of limited some of that functionality as well.
Right. But the good news is we did seem to come up with a really innovative use for these OUDP test bursts when it comes into Flavio's initial challenge of, now the downstream where we used to transmit our leakage test signals is now the upstream. I can't transmit downstream signals on the upstream from the head end, but I still need to test leakage in that aeronautical band. So here comes a use for those OUDP test bursts. So how is that? How are we using OUDP test bursts for leakage? Flavio, I'll let you take this one first.
Okay, well, essentially what we're doing is to put it simply, okay, we are configuring through the CMTS, we are configuring or provisioning, if you want. Okay, I don't know what the right term would be, but we're essentially telling the modems, okay, to insert a certain test burst in the sequence, okay, between the different modems within the node, okay. And the leakage detection equipment, okay, needs to be configured with the exact same parameters, okay, in order for it to detect, okay, that OUDP burst, okay, and that becomes, if you want, that becomes the signal that we are tagging off, okay, to confirm that there is a leak coming from the plant in that aeronautical band area, okay, that is now in the upstream.
Okay, so the test burst comes from the subscriber's home. If it leaks out, you're going to receive it somehow, correct?
Correct.
Okay. So Jason, on the CMTS side and the cable modem side, how does this configuration happen?
Well, what kind of what Flavio was talking about, we'll define a number of frames that'll be in a burst, and then we can define a gap between them if you want, and then we can define how often we want this to cycle through. And we'll define a frequency range that burst is going to take place in. And when we do that configuration, what we'll actually build is another service flow that goes out to the modems, and we call it an OUDP burst test. And the modems will then transmit in a given order, so that it'll always be in a set order for different modems. They'll then transmit on that frequency in the cycles that they're running through. And then that's where Flavio's equipment is geared towards that, looking to see if they see any signals coming out in that particular frequency range.
Cool. So John, how, if looking at this from an RF perspective, how much signal can we expect to get out of a subscriber's home from a cable modem?
So, the modem and the CMTS negotiate their transmit levels, right? So whatever level is needed to hit the CMTS or RPD remote PHY device at 0 dBmV, it is what it is. The modem will put out what it needs based on the passive loss, the coax loss, the tap it's going through, return path, step attenuators, all that stuff. And, we try to engineer and design our plant so that modems are transmitting near 45, 48 dBmV. That would be a nice number, knowing where the modems max out. And that could be 50, 51, 53, depending on a 3.1 modem versus a 3.0 modem and how many channels are operating. So, power level wise, you could be pumping out, 48 dBmV. But part of the OUDP per test burst is, and Jason, correct me if I'm wrong, you can specify the frequency. You can specify specific MAC addresses, or you might say, this entire service group, or activate the test burst on every single MAC domain. Maybe Jason can elaborate more on, how do we determine which areas are going to be active?
Yeah, you could do a lot of configurations on how you do that. The way we envision it, though, is probably all upstream 3.1 modems. You're going to have them transmitting, just so that you could detect whether they're having leakage. But you're right. You can have a subset of modems that are only transmitting on it. So a lot of different configurations that you could have. But also, what you want to do is you don't want to have thousands of configurations within one box. We kind of have a configuration where you can apply one configuration globally, and then we'll just look at all the line cards. And if there's an OFDMA channel that's active with that frequency band that you're trying to test on, we'll then have those modems get put into that test.
It's interesting also, Brady, about what if you don't have any 3.1 modems in that area? Well, if you don't have 3.1 modems, you're probably not doing a 204.
Probably not. You're not doing it very well.
You're upgrading to 204 because you're going to make money on it, right? And people are asking for more speed.
The thing too, with the upstream is that it's bursty by nature. So if you don't have any, whereas the downstream steady, if you don't have any 3.1 modems, even if you configured that channel, there's no one to transmit back on it. You won't get any sources.
Right. So that's, I think, a good point that you're making. This is something that you have to have DOCSIS 3.1 modems. It's not something we can do with 3.0 modems or any earlier version of DOCSIS modems, correct?
No, correct.
Right. So where are we at in the process of doing this type of testing today? Are we working with Cable Labs or anything like that, Flavio?
Yeah, Cable Labs has been active in this developing the specification, if you want. Okay, and right now, okay, there are several operators that I'm aware of, any that are deploying DOCSIS 3.1, of course, and will be migrating, towards a high split network. Okay, so that's another one of the challenges that we're basically facing as far as leakage detection and reporting. Okay, is that equipment that's set up for doing OUDP detection obviously is not able or is not going to do the traditional legacy detection. Okay, and since the cable operators obviously will not be able to turn the switch on overnight and have everyone up on 204 with DOCSIS 3.1 modems, it poses a challenge where there has to be some way to transition between the two technologies.
Well, do we have a solution for that? I mean, how? Because I think you raise a really good point. When we are transitioning, we still have to do both.
Right.
What is the solution to that?
There is some solutions for it. Okay, there is a possibility given with the electronics that are being used today. Okay, there is a way to if you want to configure the detection equipment to do both in an alternating mode. Okay, so the detection equipment is in the same frequency range. Okay, so the detection equipment will try to look for one type of legacy signal or the OUDP signal, and if it locks on the UDP signal, then it'll use that to detection. So there are ways of doing it. It's not perfected yet, but there are ways of doing it.
Has there been any discussion of a modem being able to do a burst in the downstream?
A burst in the downstream.
Yeah.
I don't.
It doesn't transmit. I mean, but
no, can't happen.
Not part of the solution, unfortunately.
Not that I'm aware of.
How about best practices or gotchas that we've run into so far in this journey of OUDP test burst leakage detection?
I could talk to some, at least from the CMTS side. Yeah. Well, one of it was on when we were talking about, we do that receive MER data, we do that duration, or you can configure it by frame duration. And when you do by this frame duration, you got to do a lot more math to back into it. And you can have some issues where you'll you could make it where you can't do your probing the way you should be able to do it on a regular basis.
Right. No, that makes complete sense. So when we're doing OUDP test bursting, or when we're doing this whole thing, how do we find out like what house the leak? Are we able to determine a specific house? Because normally when we're doing leakage testing, we're driving around in vehicles, and that vehicle is able to drive down to maybe a break in the coax cable, or an amplifier with a loose connection, or maybe even a subscriber's house that has a bad drop. With this new concept of OUDP leakage or test burst leakage, what did you call it?
We call the service flow an OBT.
OBT. With this ODP and leakage, are we able to do that same type of thing where we could actually drive to a subscriber's house that has a bad drop and is leaking signals out?
Yeah, absolutely. The principle remains the same. Yeah, the signals are coming, or the detection signals are coming from the modems, not all at the same time. Like Jason mentioned, they're toggling through. So whenever you're driving around doing a ride out, if you want, okay, within the plant, okay, the same approach comes up. If you detect the signal, there's a leak there that's valid over 20 microvolts, okay. Usually today's systems, what they do is they geolocate the point, okay, where the leak was detected. So whether it's coming from the subscriber or whether it's coming from the plant, okay, the same approach works.
Let me reiterate and key in on what you said, geolocate. Mm-hmm. So I could be an RF tech doing my daily business, working on the customers, but my rig, my van is set up for detection, but I'm not actively looking for detection, or I'm not troubleshooting leakage. I just happen to have a van that's detecting it, but it's being logged with what do we call it? Information.
Geolocated point.
So later on, there could be a different tech that's his job to look at all the data and then go out and fix the leaks.
Mm-hmm.
Okay.
Correct. So that typically today with the systems we have, okay, so the events, leakage events are geolocated and plotted on the mapping application that that's overlaid over the MSO's or the customer's plant. Okay, so it's logged. It becomes a valid leak that needs to be repaired, and then the maintenance technician will go out to that geolocated point that's been recorded and find and fix the actual source, okay, of the leak.
So you could sort it. You could sort it by worst case, and then
exactly
put out the bigger
intensity. That's right. It could be by intensity. Obviously we want to hit the highest first, okay, and work your way down.
And I wanted to reiterate also, Brady, that we're talking about 204 for higher upstream speeds, DOCSIS 3.1, mm-hmm. But FDX also is a solution, but that's DOCSIS 4.0. DOCSIS 4.0 FDX has no diplex filters, so that was sort of another way around worrying about leakage detection. You could still transmit your normal downstream leakage signal because you could have overlapping upstream and downstream spectrum in an FDX solution. Mm-hmm. But that brings its own difficulties, technical challenges as well.
We'll cross that bridge when we get to it.
Yeah.
Well, speaking of bridges, we do have a subscriber question that came in. It's not really related to OFDM leakage detection, but is related to DOCSIS 3.1. Jeff asks, is it normal for OFDM PLC upstream channel to be set to 850 megahertz? And he says he's on Xfinity cable. So
downstream.
Yeah, I think he must be meaning the downstream signal, because the OFDM is always a downstream signal. The PLC itself, Jeff, can be set really anywhere in that channel. I'll let anyone else take that if they know of recommendations of where the PLC should be set, or where they've seen operators typically set the PLC. If it's 850 is not a good frequency due to LTE or anything. Guys, you have any thoughts?
Yeah, I mean, what we normally put it right in the middle of the channel. If by default, if no one sets it, we're going to pick that. John and I did a lot of testing early on with errors and injecting a load of noise onto the PLC. And it takes an awful lot to drive that down. I've heard of very few customers that have had a problem like with, LTE type of thing driving down the PLC. It's robust.
What's the modulation again on PLC? Like 16 QAM or something?
I think 16
pretty
QAM.
robust.
Is it 16 or QPSK for the PLC?
I think it's QPSK for the PLC, and it's robust. But that said, I've seen someone knock that down with error. So you don't want your PLC to go down, and if you got to get it out of the way if you got really bad stuff. But usually, if it's that bad to interfere with the PLC, you ought to put an exclusion band around that part of your spectrum anyway, because it's going to mess up the rest of it too.
Yep, there's going to be other issues.
I would say an example would be, what if you're 700 to 900 megahertz OFDM, and maybe an ounce of prevention with a pound of cure, you just stay away from where you think LTE is. It's really not that bad. But what if you have house amplifiers that roll off at 750?
Yeah.
You don't want to put your PLC at 800 if in some cases it's not going to work at all, maybe. I'm just thinking out loud, I might not put it in the roll-off where I might have roll-off.
Yes. And house amp, so we did a part of a Cable Labs working group that I'm on. We're doing some analysis and stuff, because you mentioned house amplifiers, John. It is surprising how many issues that house amplifiers will cause. So word of caution to anyone out there, whether you're a technician or a homeowner and you run into a house amplifier, keep an eye on those house amplifiers. They cause lots and lots of issues for you. Troubleshoot them first is what I'm getting at. So anyone else who has questions for us, please get those into the chat soon, because we don't have much more time left on this podcast. or live stream. So OUDP and leakage, we kind of covered the hows and the whys. Implementation. So how are vendors are vendors implementing this? Is this something theoretical at this point? Are we actually seeing products out there that can do this, that can actually put this into cable operators' hands? Flavio, I'll let you start on this.
Yeah, well, as far as the test equipment, or if you want the detection equipment vendors such as ourselves, okay, most of us have already implemented various solutions, okay, based of course around OUDP test burst detection, okay. There's probably different variations in the way it's being done, okay. As far as the CMTS vendors and cable modem vendors as well, okay, they also have started implementing means of configuring, if you want, the cable modems. There are different ways of doing it. I've witnessed tested when we did testing with different vendors, okay. I've noticed differences in the way the cable modems are programmed and so on. But what I did realize, okay, in seeing the testing, is that there's not really a standard way of doing it yet. Okay, so there are little discrepancies between the way the vendors apply the programming to the CMTS in order to initiate these OUDP test bursts. So I would assume, obviously as time goes on, as we have more experience with it, okay, there may be there's going to be some common things that will be implemented within all the vendors in order for all the detection equipment as well to be compatible with it.
Okay, so if I'm a cable operator today and I'm starting to expand my plant to a high split, what do I have to look at on the CMTS side and cable modem, Jason? Do I have to make any upgrades? Do I have to upgrade my firmware, my modems, or anything like that in order to start thinking about supporting OUDP leakage testing?
Yeah, we added the support back in April last year, so it would have been like a 17.6 release for Cisco. We were at the Cable Labs kind of sponsored event. It was at Charter hosted it in Denver that Effigis was at, along with all the rest of the test set equipment as well. But yeah, you need to have that code where that feature was enabled. Again, like I said, we weren't using it originally, for OUDP selection. But you need to have that feature in it. On the modem code side, again, there have to be the modem might have to have some firmware upgrade, but that firmware has been available for around a while as well. One of the things we didn't go into, if we got a second, that just, what we see on the CMTS when we're scheduling it, we just schedule the modem to transmit these bursts, and then we note that we actually receive that burst from the modem. Some of the early codes that were on some modems, we would tell the modem to transmit that burst, but we wouldn't actually get the modem wasn't doing it. You need to have in the CMTS to know that when I told him to transmit, that he actually transmitted and we received it. That way you know that he's a source that's actually generating that traffic that can be measured. So there was some early versions of code that maybe it didn't recognize what we were doing with the burst test, that a firmware upgrade fixed that. But all the modems that I've dealt with with any kind of recent code, they support that as well.
Yeah.
Let me give you a little gotcha that Jason and I've seen, is that kind of like CMTS cable modem trying to be smarter than everybody else. And a lot of the 3.1 modems have maybe an 85 or 204 filter that can automatically go 85 or 204. And when we first started reading, I think it's a TLV or something like that. If you configured your OFDMA below 117, the cable modem would say, hey, because 117 was a legal filter according to 3.1 spec, but no one does at 117. And in the modem, because it was not above 117, would flip on its 85 megahertz filter, and it wouldn't lock onto the OFDMA. So the workaround was just make sure you configure your OFDMA above 117, and then the 204 filter would activate. So I'm just thinking in my mind, if someone's doing OFDMA just a 115, and then they try to do the burst at 137, maybe it won't work. And it's probably not working in the first place because the 85 filter kicked in for the modem itself.
No, that's a good input. When you're doing this, does a subscriber have any negative impacts from running these bursts? Is that another gotcha? Are we impacting subscriber speed?
Not, it's minimal. What we we allow you to configure that burst to be as long as, or the frequency is as big as you want. What typically people are going to configure is something like 1.6 megahertz for 4 mini slots. So we're talking about small percentages, especially typically when you're going to need this, you moved up to 204. Now we're talking about those bigger, 96 megahertz wide channels. So you're probably talking less than 1% loss in channel capacity.
Right.
Yeah, I got a question now, because I was under the impression that during the test bursts that were going on, there was no actually live data on at that time. Am I wrong?
It's not right. Well, I mean, there's live traffic going on. We use interval usage code 13, and that's what the mode's sending, but it is not sending data. That's right. So that's why you lose that 1% of the traffic. Okay. What it is that you'll lose it for the burst duration, and if there's a gap between it, we'll have it as be a gap. There could be a cycle gap at the end. We can send probing in there. We can also send data in there if we're not sending probing. So you lose a little bit less than that. But you're right on, Flavio. We are not sending any data in that 1.6 megahertz at the time when we're actively sending those OUDP test bursts.
Awesome. Okay.
Well, Jeff came back. He was the person who asked about the downstream RxMER question, and he says the reason he asked was he had a Motorola MB8611, and it started rebooting after filling up the log with tons of sync timing failures, no range responses received, T3 timeouts. He switched to a Netgear CM2000, and he said that fixed, and now it stays connected. It showed the downstream and OFDM frequency differences between the two modems. So I think that's probably what he was seeing issues with. And I'm not sure. Does anyone know what the difference is between, I believe that both of those are DOCSIS 3.1 modems, the CM2000. I know I have one behind me.
Yeah, I'm not familiar with the 8611 number.
I know that is also a 3.1 modem as well.
Okay, I'm not familiar with that one.
Yep. So.
No.
Yeah, I'm not sure, Jeff. I'm not sure we have an answer for you there, but 850 megahertz on the PLC, as we talked before, there's probably not a problem with that. And as Jason mentioned, it's darn hard to kill the PLC. If you do, you probably have bigger problems going on in the plant.
Right.
So, yeah, sorry, Jeff, I don't have a solution for you, and I don't think anyone else on here is. Yeah, he says yes, both are DOCSIS 3.1 modems. I'm not sure on that, but it is interesting that switching the modem resolved your issue. Glad that did resolve your issue for you. So on the OUDP leakage side, guys, is there anything we have not covered today? Anything you want to add in before you wrap up?
What's the typical frequency we would be using? Flavio.
For OUDP, it's normally around 138 is what is being used. Although that too is something that that us personally we're looking at is actually to do it also elsewhere. Okay, within obviously within the good portion of the aeronautical band, but typically, okay, so right now it's being done at 138 with a 1.6 megahertz channel.
And is that because we've used typically 138 as a downstream test frequency as well, or?
Well, 138 is it's a common spot, okay, that everybody uses, and then obviously it's right in the middle of the aeronautical band, okay, and nothing's being really put there other than a lot of public. There's all kinds of radio astronomy and all kinds of other usage in that slot of spectrum. So that is a very common frequency that's being used in an analog and in the digital environment as well.
Makes sense.
I had a couple of things maybe just that we didn't necessarily come across, but some of them were, we use the pilot patterns. That's actually what the test set test set is keying on to make sure that they know this is originating from an OFDMA channel as opposed to just some over-the-air interference. Those pilot patterns that pretty much universal the test manufacturers want to see are non-boosted pilot patterns, and they're the pilot pattern that has the most overhead in it. That's really not a problem on this IUC 13, but what does come into play is we support boosted pilot patterns and non-boosted pilot patterns, but the spec doesn't allow you to mix those on the same OFDMA channel. So if you're doing this, you're going to be using non-boosted pilot patterns. Kind of a moot point. I don't think a lot of people use these boosted pilot patterns in the past, but just to bring up, if you're doing this leakage detection, you're going to not use boosted patterns. That means you're not going to be able to use boosted patterns anywhere else on any other IUCs on that same channel.
How does that impact the modem performance, Jason?
Yeah, not a bunch. What it does when you boost the pilot pattern in there, it's a different pattern. Actually, you need less pilots, therefore you get a little less overhead with the pilot pattern. When you use boosted pattern with non-boosted, then you're going to have more pilots in a given mini slot, so you end up having a little bit more overhead dedicated to the pilot pattern.
All right.
I think the spec says the boosted pilot for upstream is 4.7 dB higher than the regular pilot patterns. And then I asked, I think Roger Fish at Cable Labs Broadcom, I said, does that affect my total power? Like, what if I'm worried about laser clipping or upstream load? And he says, just because that's up by 4.7, there's not that many of them and it's bursting through. He says it might be a dB, half a dB more.
But a dB could be big when we start getting these big channels now, your max transmit power is going to drop and everything may start mattering then. I don't know.
I was also thinking, you asked about, Brady, you asked about that in performance hit to the customer. You know how we schedule our traffic left to right in frequency on OFDMA. So if I were to do my last OFDMA block from 108 to 204, that's a 96 megahertz block, 108, and then if I'm doing 138 for my boost, when no one's really bursting a gig traffic on the upstream or something like that, you're going to see a spectrum analyzer grab from the left to the right. But then you might see one little burst at 138 because that's my OUDP test burst.
Right. So
I'm just thinking like what you might see on the spectrum analyzer. Usually it starts filling from the left to the right. If someone's trying to do 1 gig from their home, you're going to see the whole thing burst up.
Right.
But many times people aren't doing that. They're doing normal traffic or whatever. And you might just put it on peak hold and slowly fill up from the left. But every once in a while, you might see that test burst pop up kind of off by itself.
Yeah, and I think that's important to realize. We're not using the entire OFDMA channel. We're just using a very small sliver of it to create our test signal that we need to measure. So, all right, guys, one last call. Anything else we want to mention before we wrap it up? Going once? Going twice? Awesome. Guys, thank you so much. Flavio, thank you for your time today. Jason, thank you. And John, thank you. So John and Jason are from Cisco, and Flavio is from Effigis. Guys, great information today. We'll be back in a week. Ron and I next week will be doing a discussion on what is a decibel. So everyone, please join us back then. Do smash that.
That's basic.
Yeah, it's basic. Do smash that that like button and hit the subscribe button if you enjoyed what you saw today. We greatly appreciate it. So guys, thanks again. Take care.
Thank you.
And we'll talk again. So long, everyone. Thanks. We're signing off.
Take care.
Bye-bye.
Yeah.